Welcome back to Forward CloudSec. Reminder, fill out our feedback surveys. The links are pinned in the channel. This talk is leveraging Azure Resource Graph for good and evil. Before we start, I'd like to thank all of our sponsors, especially our bronze sponsor, JupyterOne. JupyterOne is a cyber asset management platform that helps enterprises map, analyze, and secure complex cloud environments. Gain full visibility into your assets and relationships between them to uncover threats, prioritize risk, and to build the foundation for your security program. For those in the room, please silence your cell phones and use the mic to ask questions. For remote attendees, we'll be looking for questions on Slack. Please welcome Darwin Salazar.
Also want to give a special thanks to all of the Forward CloudSec organizers, Scott Piper, Chris Ferris, Patrick Sanders, Joe Thompson, and the rest of the folks that make this possible. It's a year-round planning thing, and last year we had like the whole COVID stuff, and so we had like a 50% show rate, a no-show rate, and so now we're back in person, and it's been freaking amazing. So my name is Darwin Salazar, and today I'll be showing you how to leverage Azure Resource Graph for good and for evil. But before we start, just a little bit about me. I'm a CSPM detection engineer at Datadog, and in my past life, I was a cloud security consultant, spent some time in IoT security as well. And below you can see some of the certs I hold and where I've been to school. And now let's jump into the fun stuff because I want to cover a lot in just 20 minutes. And so first of all, what is Azure Resource Graph? How many of you are familiar with Azure Resource Graph? Can I see by a show of hands? Okay, so 3 or 4, maybe let's say out of 12. And so this is not surprising to me because it took me 2 years of working in Azure security before stumbling upon Azure Resource Graph. And then once I started playing around with it, I was kind of mind blown by all of its like powerful capabilities. And so today this is, I'll go over some of those use cases that I used to use Azure Resource Graph for as a consultant, and some of the red teaming scenarios for which you can use Azure Resource Graph as well. So first, as I begin digging deeper into what Resource Graph is, I wanted to see how Microsoft markets it, how they market it, and also how do they define it. And so what I found is that they define it as a powerful management tool to query, explore, and analyze your cloud resources at scale. And they do a very good job of capturing the essence of Azure Resource Graph in a concise manner, and I absolutely love this definition. They also add that it allows for rich aggregation and parsing of granular resource properties, which we'll go over. And also, a feature that is now in preview is the tracking of changes made to resource properties. So resource change history over the past 14 days. And how I would define it is Azure Resource Graph is kind of like the all-seeing eye for your entire Azure asset inventory, and it provides you very deep and granular insights about your resources. And so what could potentially go wrong if an attacker gets a hold of this service? This is what the user interface for the Resource Graph Explorer looks like in Azure Portal. It's a free service, it's built in, it's enabled out of the box. And so here you could see on the left-hand side, you could filter on which scope you want to query at. You could query at the tenant level across all subscriptions, or you could focus on a single set, a set of subscriptions. And you could even hard code and filter on resource groups within the query box there. And so at the bottom, you could see the results. Resource Graph is extremely efficient. It dumped an entire asset inventory of 96,000 resources in less than a second. That's mind-boggling. And on the right-hand side, this is where we'll be spending most of our time. It's the See Details pane where you could get those very deep and rich insights. Now, I want to go over what the See Details, a preview of what the See Details panel looks like. And here I just queried for key vaults, and then I popped open the See Details panel, and you can see here in the properties, I have access to all of the permissions that my user principal that I'm logged in with has to this specific key vault. So I can unwrap the key, I could delete the key, I could get, list, create keys, and things of that nature. And so it's different. This properties panel is going to be different for every resource, obviously. And we'll be looking at AKS, Azure Container Registry, et cetera, in the live demo. So why is Azure Resource Graph so powerful? And one thing that I wanted to cover also is that Azure Resource Graph is actually the service that powers the Azure search bar, and so it has God mode level visibility across the entire Azure estate. The other thing is that it only requires read a role to the scope at which you're querying at. So say you're an attacker and you've compromised an account with only the reader role across the entire tenant, you get to have visibility into very granular insights about resources, and you could pick your spot and identify attractive attack targets with just the reader role. It doesn't require installation, say, of a open source penetration testing tool, which can sometimes be difficult to implement or can be noisy. And also, as I previously mentioned, Resource Graph maintains a record of every single change made in for all of your Azure resources. Azure Resource Graph is also highly compatible with various languages, including Go, Python, Azure CLI, and PowerShell. And one of the strongest points about Azure Resource Graph is that it allows for cross-subscription querying. So with PowerShell and Azure CLI, you have to set the subscription at which you're querying at, and you have to do your queries recursively, which is not only tedious and time-consuming, but is extremely noisy from a detection perspective. And another thing that I found from my research is that Azure Resource Graph actually allows you to query cross-tenant if the organization uses Azure Lighthouse. And Azure Lighthouse is simply a management solution for organizations to be able to manage multiple tenants at once. So think about the use case where you have a managed service provider that manages the SOC for multiple organizations, and they want to have visibility into the resources across all of these tenants. They can do so using Azure Resource Graph, but that is a very sharp double-edged sword, because now if an attacker gets a hold of Resource Graph on that cross-tenant parent organization, then now that attacker has visibility across the entire estate. And here's a meme of Resource Graph exerting its dominance over Azure CLI and PowerShell because it's so much more efficient and stronger than PowerShell and CLI. And this is another thing that really surprised me, is that Azure Resource Graph queries are not logged. It's a bit of a gray zone. So you have the scenario where an attacker could be squatting on an environment and just running endless amounts of queries, trying to find a very attractive and high attack target of high criticality, and it would go undetected because it's not generating any logs. And I'll show you documentations and a video, and I have some of that in the appendix as well, and I'll hand over this slide deck to the Forward Cloud Tech team so that you could dig through it as well. So real quick, how does Azure Resource Graph work? And I promise you we'll go over to the demo right after this. And before jumping into kind of like the diagram here, I want to talk a bit about Azure Resource Manager, which is essentially the backbone and the management fabric layer of Azure. It allows for CRUD operations on resources. It also powers things like Azure RBAC. It allows for resource locking and deployment of infrastructure as code templates like Bicep and Azure and ARM templates. So say you create or modify an Azure resource. Azure Resource Manager API notifies the Resource Graph API of the change that was made, and then Resource Graph records this change into its database. Fairly simple, right? And so for anything that happens outside of Resource Manager's purview, say any configuration drift and things of that nature, Resource Graph API addresses this by running a full scan of the entire environment on a recurring basis so that it can maintain its data current and up to date. And then from there, we can query with our language of preference. As I showed, it's compatible with Go, Python, et cetera. But for today's purpose, we'll be focusing on Kusto Query Language. And now for our demo and our scenario. So let's say your company has just acquired a small startup. This small startup has no security team, and you need to rapidly orient yourself with the Azure tenant. Your goal is to get an asset inventory of all of the Azure resources so you can get a better understanding of the threat landscape, and to identify resources that pose immediate security risk. And here's another meme. It's 2022. I'm not sure why organizations still find themselves in this predicament where they acquire a startup that has minimal to no security team, but it still does happen. Working in security is fun. So now to our demo. So this is how you can locate and get to the resource graph service within the portal. You just type it in the search bar. Here's the filter. You can filter on the tenant level, different management groups, and the subscription. And on the left-hand side, you can see the different resource providers that it supports. It has high compatibility across most of the resource providers. And here are the tables from the resource graph database. You have some very fun stuff like Kubernetes configuration resources. We'll be focusing on resources today, and then there are a bunch of preloaded queries that you could play around with that Microsoft has provided. Here you can see I just ran the resources query, which gives us a dump of our entire asset inventory. And sub-second, it gave us our full asset inventory. So I've located this Azure Kubernetes service cluster, and I just want to peer into what some of the properties are. Here I can see the full network profile, what network plugin it's using. I can see the pod CIDR. I can see DNS service IP, et cetera. I can see some things about the security profile as well. Very granular insights. Like it's actually insane. You can see what's the max number of pods, whether or not auto scaling is enabled, and several things later towards the end. And also whether or not it's integrated with Azure Policy or Azure Key Vault service. If it has RBAC enabled, therefore Azure Active Directory is its main identity provider. And now digging into some of the properties for a container registry, you can see if this container registry is encrypted, which it is not, and whether or not it has public access enabled, which it does. And so this is a container registry that is publicly accessible. And here you could glean more details about the registry, but it just goes to show that the properties are different for every type of resource, and you could get very deep insights. But now we're focused on imminent security risk, and we know that there have been a lot of organizations that have ended up in the news because of publicly exposed S3 buckets or blob storages that have led to sensitive data leaks, and ultimately them ending up on the news. And us acquiring the startup, we do not want to end up on the news. And so I do a keyword search. I parse out the allow blob public access string from the properties, and I'm looking for where the value is equals to true. I found 2 instances, but without additional context, who cares? This could be, these 2 storage accounts could be living in a non-production environment, QA or dev. So what we want to do is add some filters and look for storage accounts that have the resource tag that would indicate that they're in a production environment, that they're handling GDPR-related data, and that they're not located within those 3 regions in the European Union. And so as we can see here, this is a publicly exposed storage blob that is in a production environment. It resides outside of the European Union, and it has European citizen data in it. And so this is one way that you can use Azure Resource Graph to look for very particular instances where you may be non-compliant or just running a very risky configuration, like a publicly accessible container registry in production. So now let's add some automation into this. With Azure Logic Apps, you can actually run that query that we just ran on a recurring basis, and whenever the result is greater than or equals to 1, you can add some automation and generate an alert in Sentinel, shoot a message off to Slack, and create a message in Jira. So here's a scenario where Azure Resource Graph has added some optimization, orchestration, and automation into your environment. Now, let's focus on a real-world example that I came across several weeks ago as I was creating this talk. And there was, several weeks ago, there was the FabricScape vulnerability, which was disclosed by Unit 42 Palo Alto, which allowed for Linux container escape on Azure Service Fabric clusters. It wasn't a cross-tenant vulnerability, but it was still a vulnerability that people should keep an eye out for. I think they ultimately rated it like a CVSS high, and that now we have an open vulnerability, open cloud vulnerability database where we could track all of this. But this query that Christoph published allows us to identify unpatched Linux containers that are vulnerable to FabricScape. And as an attacker, this is extremely attractive because you can, just with this query here, identify resources that you could exploit with some of the latest vulnerabilities. And so, as you've seen, there have been a numerous amount of vulnerabilities across all cloud providers over the past several months. And with AutoWarp being one of them, Synlapse being another one. And if you want to and get the chance to, you can play around with some of the vulnerabilities within this database here, which the Wiz team will be presenting on in about an hour, and see if your organization is vulnerable to any of these, vulnerabilities, or may have been impacted before they were patched. So now let's jump over to our red team scenario. I'm winding down on time here. So you've been hired to execute a red team exercise on a hospital's Azure environment. You gained initial access to an account with reader role. What can you do next? So this is where we inflict some pain. And here you can look for VMs with public IP addresses, and you could glean information about the operating system image. This is a triple join, so a fairly complex query. But network interface cards and public IP addresses and virtual machines are 3 separate resources within Azure. So we have to do the triple join in order to get this information. But here you can see I have 2 machines that have public IP addresses. And I could get information about the operating system image. And this one seems to be a domain controller. I will fast forward. And here I'm simply doing a rule dump of non-default NSG rules. And network security group rules is similar to VPC security group rules. And here you can see I have a rule that allows traffic from any source over port 3389 within the same subscription as our VM, our domain controller. So there's some, I'll let you use your imagination, but there's some fun stuff that we can explore with that information. Now, another meme. So I mentioned earlier that none of this was logged. And the reason why none of this is logged, from my understanding, is that we are not interacting with any of the resources. We are not modifying anything. We're not creating any resources. And so under which category would resource graph queries logging fall under? The answer is none of these. And so activity logs captures any write operations on the management plane, and resource logs capture any operations in the actual data plane of resources. And then obviously it wouldn't be captured in the Azure Active Directory logs. And so to conclude, Azure Resource Graph is a double-edged sword hidden in plain sight. It generates no noise compared to its alternatives like Azure Write, Blob Hunter, and several of the other Microburst, PowerShell, and several of the other open source tools. And it's highly compatible across numerous languages in Azure services, and it has endless use cases. And if you want to explore and play around and get your hands dirty with KQL, I've added a ton of different queries that you could get started with in my GitHub repo, and you could just click the link down there. I'll also be giving a KQL Kung Fu workshop at DEF CON Cloud Village on Saturday the 13th, and I'll be giving an extended version of this talk at Texas Cyber Summit in September. And yeah, that'll conclude my talk. Any questions? And most importantly, thank you all for being here.
Thanks a lot, Darwin. So just a couple of questions for you. Your abstract kind of mentions a little-known service combined with God-level visibility across your assets, and whenever I hear those two things right next to each other, I get really nervous. It makes me think that it's sort of an unexplored area. Are you aware of sort of other instances of this kind of like toxic combination?
So my security career is fairly young, and so I can't like reach back into my knowledge base and provide a specific example or instance where something like this has been exploited in the past. If anybody in the crowd wants to answer that, definitely, but I'm sure it has happened in the past somewhere. Sure. Yeah.
And then I was just kind of curious of what's the resource coverage like for this graph view? Is it all resources, or are there some resources that aren't? Is it like maybe an attacker might try to concentrate on creating things that aren't covered by it to stay hidden?
Very good question. And so reading the Microsoft documentation, the answer to that question is it covers most Azure resource provider APIs. And so if I just extend all of the resource providers on the left-hand panel that I showed, it covers like artificial intelligence, big data resources and services. It's fairly extensive for what it's compatible with and what it covers. And again, that's probably like another advantage that it has against some of the open source pen testing tools.
Great. Thank you very much. I'll give one. Oh, here, question from the crowd.
Hi. So I had a question about the Defender perspective.
Yep.
Is there a reason that you would suggest automating those types of queries over implementing something like Azure policies for like public storage accounts and blobs?
Yeah, so
and other misconfigured resources.
Very good question. And so in this scenario, we just acquired a startup. We're just getting a lay of the land. We want to, on day one, immediately identify what we're vulnerable to. You could definitely deploy some Azure policies in audit-only mode and be able to identify that. I think this is a way to get much more context past Azure policy and focus on specific vulnerable instances or risky assets. And you could also add automation where, with Azure policy is an extremely powerful service, so it's tough to kind of compare it to that. I would just say in this scenario, since it's a startup, you're just getting acclimated. You do not want to make any decisions on day one other than identifying very risky things. So.
Great. Thank you very much. We'll give one final round of applause to Darwin.